Hi, I'm George Woodbury from College of the Sequoias in Visalia, California, and in this video I'm going to introduce you to the Pythagorean Theorem, one of the most widely known results in all of mathematics. The Pythagorean Theorem has to do with a right triangle. Now, a right triangle is a triangle that has a right angle as one of its three angles. A right angle is a 90-degree angle. And you can think of it as the perfect corner that you would see in a square or a rectangle. And if you think of it this way, this looks a lot like a rectangle that's been sliced in half diagonally. Okay. A little terminology: the longest side of the triangle opposite the right angle is known as the hypotenuse of the triangle. The other two sides are simply called legs of the triangle. Now, if we label the two legs as A and B in either order, and we label the hypotenuse as C, it leads to the result known as the Pythagorean Theorem, which relates A, B, and C in a formula: A squared plus B squared equals C squared. Basically, if you take the length of the first leg and square it, and add that to the length of the second leg squared, that sum will equal the square of the hypotenuse. So again, that's A squared plus B squared equals C squared. Typically, in a lot of problems, we'll know the two legs, we'll square them, add them together, and then take the square root to figure out what C is. Or if we know the hypotenuse in one of the legs, we'll subtract the square of that leg over and take the square root to find the other leg. Let's take a look at some examples. First, two legs of a right triangle measure 6 centimeters and 8 centimeters. Find the length of the hypotenuse. Let's begin by drawing a right triangle. A picture is always a great idea. And we're told that the two legs are 6 and 8 centimeters. So the unknown side is the hypotenuse. In the Pythagorean theorem, A squared plus B squared equals C squared. We can rewrite this as 6 squared plus 8 squared equals C squared. 6 squared is 36. 8 squared is 64. And 36 plus 64 equals 100. Now we have a squared variable equal to a constant, so we can take the square root of both sides. Now, in previous situations, we took both the positive and negative square root, but in this geometry problem, the hypotenuse cannot be a negative length, so we're just going to worry about the positive square root, and we find here that 10 is equal to C. Slightly different problem here. One leg of a right triangle measures 7 inches and the hypotenuse is 11 inches long. Find the length of the other leg. So I'm going to start with a right triangle again. Not necessarily to scale, just so that I can label the legs and the hypotenuse. One leg is 7 inches. Let's put that here. I could have put it along the bottom instead. The hypotenuse is 11, and I'm missing this leg. I'll call it B. You could call it A if you like. Again, the Pythagorean theorem: A squared plus B squared equals C squared. Put in 7 for A and 11 for C. 7 squared is 49. 11 squared, 11 times 11, that's 121. Let's go ahead and subtract over the 49. B squared equals 72. So to solve for B, I'm going to take the square root of both sides. Again, ignoring the negative square root because this has to be positive. B equals, I don't know the square root of 72, but I know that 72 is the same as 36 times 2, so I can get a 6 out of there. 6 square root 2 is the exact length, and if I go to the calculator, that approximates to be 8 0.485 inches. By the way, if you're going to just go ahead with a calculator approximation, you could have done it right here at square root of 72, which might be a little easier into the calculator. Again, if you know both legs, you add the squares together and then take the square root. But if you know one leg and the hypotenuse, like we did in this example, you're going to have to do a little solving before you can take the square root. All right, so if you have any questions or comments on this topic or this video, or if you have a request for a video that I can put together for you on YouTube, you can reach me through the contact page on my website, and that address is georgewoodbury.com. Thanks for watching and good luck with this.